Okay, so my name is Wajahat Chima, and this is homework number 10, question number 1. So, we're given Poisson process number n, t1, t2, random variable, equals k equals e to the negative lambda t to the k power, k factorial, and we're given this is a Poisson process, and we're given that t equals t2 minus t1. So just to give you an idea of what the graph will look like, it will look like this, where all of these will be independent increment processes. So for part A, we have to find the expected value of xt. So in our previous course, we've used Poisson, and we found out that the expected value of x is just lambda, but over here we have, this is a Poisson process, so we have a time element, so we're gonna have to figure this out here. So e to the xt equals ke negative lambda t to the k factorial, just k times the function. So do the summation here. The summation equals 1 because the summation of all probabilities from 0 to infinity always equals 1. We're going to do the derivatives, and then we do a little bit of algebra here. If you want to look at it, you can look at my work right here. And we end up with lambda t e to the lambda t so far. And then over here, you can check out my work here too. And then the final answer is lambda t. So that will be part A. For part B, we have to find the autocorrelation for T1, T2. So we have two cases where T2 is greater than or equal to T1, and where T1 is greater than or equal to T2. So for the first case, using this case, T2 greater than or equal to T1, this was the formula, if you guys remember, for autocorrelation: expected value of xt1 expected times xt2. This is how we used to solve it, because T2 minus T1, according to the graph before, we have to have that element in there, right here. And as you can see, we have a second moment in there. So to find the second moment, we use e to the x2t equals k to the second moment, excuse me, e to the negative lambda t to the k over k factorial. So again, we do find the derivatives, do some algebra. As you can see, we're looking for the derivatives here, and end up with lambda t plus 1. You can plug that back into this right here, and just work around the algebra a little bit, and you get lambda t1 times lambda t2 plus 1. So, and then the autocorrelation would just be lambda minimum t1 comma t2 times lambda t2 plus 1. Excuse me. And in the case where T1 is greater than or equal to T2, it would just be switched. Or T2, autocorrelation T2 comma T1. Lambda minimum T1 comma T2, lambda T1 plus 1. And that's part B, and that was question number 1. Thank you for watching.